Hey guys, welcome to another video. Today, another question from the Nice Question series. Today's question comes from the Extension 1 syllabus from the Sydney Girls past paper from 2024 in the topic of differential equations. Now, you know how I love a good applications of differential equations question. Today, well, I've been waiting for this for a while, right? A question that relates to applying differential equations to the context of chemical reactions. Now, whenever I say differential equation applications to my students, there's generally four buckets right now that questions are asked in, right? One, there's the simplest one is when there's like Newton's law of cooling and heating, right? It's probably the easiest one. There's logistical growth, right? Where you have population growth, etc., or bacteria growth that is in a restricted area or restricted region where the growth is capped. The third one is mixtures and solutes in a tank, right? And the last one, and I've been waiting for this for a while, chemical reactions where two or more, right? Two or more substances combine to create another substance. Now, today's question, I really like it. Hope you guys do as well. Now, before I dive in, as always, if you haven't already done so, please subscribe to the channel, like the video, and tell your friends. Guys, let's dive right in. All right, Sydney Girls, let's break this question down. Now, there's a lot of words here, so let's see what we can do. So, two chemicals, C1, C2, are put together in a solution where they react to form a solid S, right? So, okay, let's just highlight that, please. So C1, C2 make S. Okay, cool. Now, the next sentence here, guys, so crucial, a lot to unpack. Let's see. I'll use different colors, right? The rate of increase of mass of S, right, is proportional, right? In science, the word proportional, you replace it like with a little alpha symbol, right? To the product of the masses unreacted present, right? So three important, the rate of increase in the mass, so dm dt, proportional to, so alpha, product means times in mass, to the unreacted C. Now, I'll draw a diagram to sort of capture that now. Right, what else we have here? It takes 1 kilogram of C1 and 3 kilograms of C2 to form 4 kilograms. So for every 1 kilogram of S, a quarter comes from C1 and 3/4 comes from C2, right? That's important, right? And I'll draw a diagram to capture that now. And then some facts initially, right, to put together the solution and 1 kilo, okay. And obviously initially, now it doesn't explicitly say here, but there is no solids at the start, right? So that's initial information. Okay, let's have a look at what we have to prove now. So carefully prove that, okay, the rate of change equation, okay. Given that, prove that, okay. I think that's pretty straightforward. And then find the aftermath. Okay, cool. All right, let's do this. So breaking this down, right? So I'm just going to go and highlight things, right? So this one here, right? That there is saying dm dt, where m is the mass of S created, right? Product, so proportional means that. Product means times, and then this guy here. Okay, let me draw a diagram now. So this question basically has. Let me draw a bit bigger than that. I wonder if it snaps. No. So perfect. All right. So I've got two of these, right? I've got. Let me scroll over a bit. I've got C1 and C2, right? And they're basically joining together, right? Chemically reacting to form a new solid substance, right? S. Now, what's important is that, so the mass of this, right, yeah, is M, where maybe I'll make it smaller just to not confuse, right? Yep. So this is solid S that's created over time, right, with a mass of M. Now, what's important is a quarter of that mass, every time I create M, a quarter of the M, so over here, right, let's say this is a quarter M, comes from C1, and then 3/4 of the M comes from C2. Now that's important, right? So if I wanted to create this substance here, I get a quarter over here and 3/4 over here. Now, what I'm really concerned, or sorry, what I'm really interested in, right? It's not so much the pink part, but I'm interested in the green part, the unused, right? What do they call it? The unreacted C1 and the unreacted C2. Right? I'm interested in this green part here. Now, what do I know about the full circle, by the way? I know that the full circle in total, right, has, what's it say? Initially 2 kilograms of C1 and 3 kilograms of C2. So initially, the whole black circle there, the whole black is 2, right? The whole black is 3. So what I'm really interested in the green section is a quarter M is used to make the pink, then the unused part would be 2 minus a quarter M. Quarter M. While this one here would be 3 minus 3/4 M. Yeah, that's really what I'm interested in now, because with that, I can create an equation that goes dm dt, right? The question says the rate of change of increase, right? The rate of increase of the mass of that is proportional, actually, right? Proportional to the product of the greens, right? So basically, I want to multiply the greens together, right? As an expression. So 2 minus, now I'll do quarter as m on 4. And then multiply that with 3 minus 3m on 4. That's the hardest part in the, well, and there's a bit of integration thereafter. But getting that statement, it's not easy, right? Now, whenever you see alpha, right, proportional to, you basically replace it with equals to k, right? Yeah, in mathematics, right? Yeah, equals to some sort of constant, right? Now, and then I'm just going to common denominator. Each one here's 8 minus m on 4. And then what's that? 12 minus 3m on 4. Now, I said this to my students, right? I said to them, you know, like when you do integration plus c on the back, because it's an unknown constant, if I multiply that c by 2, it's still c, right? You're multiplying unknown constant by c, by a number, it's still unknown, right? Why am I telling you that? Because this equals to k here. If I divide that by 4, divide by another 4, it's still k. I guess what I'm trying to say is, no matter what I do to multiply or divide this k number, it's still an unknown constant. Now, the reason why I'm telling you that, and also, just for completeness here, when I factorize, when I make that into, take out the 3 there, and make that what? 4 minus m. And then see that constant there? The 4, and the 3, I'm going to merge it all into the k. Right? Bring it all into the k and just make it k. Yeah, make it all into k. So then you get dm dt equals to k, and the only brackets left are 8 minus m and 4 minus m, and that's exactly what they want you to prove, right? How's that, guys? It wasn't easy, right? Not easy to sort of translate all the English into mathematics. That diagram hopefully helps, right? That diagram hopefully helps. Now, once you get, by the way, that's 3 marks. This is an 8-mark question. If you couldn't do part 1, I say to my students, use it to integrate to do part 2. Don't lose out on the 5 marks in part 2 and part 3, yeah? All right, let's carry forward. So it feels like I now have my differential equation set up for me. So I got DMs, right? And I'm going to group together the M statements, and for DT, I'll put the constant with it, and then move the pinks on one side, move the greens on the other, and then integrate both sides, right? That's part 2. So let's get cracking on that. So I'm just going to move this guy. Ooh. I'll move this guy up here. Let's see. Move him over here. I'll just move everything down a bit. Okay. Call this number 1. That's done. And then over here, let's get rid of these. Right. Got number 2. All right, so I've got 1 over 8m, 8 minus m, 4 minus m, dm equals to k dt. Now, guys, it's really important for you to understand, right? And this is extension 1, right? You can't integrate this, or the techniques that are available to you don't allow you to integrate something that has a product of 2 brackets on the bottom, right? A quadratic factorize on the bottom. That's a 4-unit technique called partial fractions. We don't know that in extension 1, so they always, right, give you something to help you, right? Something to help you integrate. So you go 1 over x, so 1 over 8 minus x, 4 minus x equals to negative 1 over that. Yeah, so they basically broke this down for you, right? And they said, right, we know you can't integrate that, so can you please use this instead? There's a 4 there, 8 minus m plus 1 over 4 there, 4 minus m, yeah, dm, which we can integrate now, right? Because once you break out the fraction, it's lnable, right? Not that lnable is a word, but there it is. Guys, kt plus c, right? Now, if you were smart about it, you take out the quarter, right? Just to clean up things and put a negative in there. So maybe switch that around so it becomes like quarter integral of 1 on 4 minus m. Actually, you know what? I'm going to big brain this, right? See that negative there? I'll leave it upstairs, right? Because m is negative on the bottom, it's actually needed, right? Plus, yeah, for my ln g, like, because the derivative of 8 minus m is -1, yeah? So I'll leave the -1 upstairs. It was a kt plus c, right? Cool. And then let's integrate, right? So that becomes a quarter ln. Now I'm gonna, this will be negative there, so that's a minus. That'll be lnable and then minus. So I'm just going to combine my logs thereafter, right? And so go 8 minus m minus, because it's subtracting, so I divide the 2 logs, right? That equals kt plus c times the 4 up. Yeah, times the 4 to both sides. 4 kt plus, now 4 times c is c, right? Is that okay? Yeah, so now at this point, should I find my constant? Feels like I should, right? So when t equals 0, there is no m, right? No m. So ln 2 equals to c, right? So sub that into there. And then, let's see what I get. Okay, ln 8 minus m, 4 minus m, was a 4 kt plus ln 2. Now, have a quick look at what I need to prove. I need to make t the subject. It's very strange. Normally you make m the subject, right? So making t the subject is actually not too bad, right? Because then I chuck the 2 over, so minus the, so I get 4 kt equals to ln 8 minus m over 4 minus m minus ln 2, which means I divide by 2, which means the denominator gets multiplied by 2, and then divide by 4k. Now, is that what they want though? Oh, they want me to find k as well. Okay. I might find k now. Should I find k now? Yeah, it might be a good idea. So when, no, didn't they give me another fact to find k? Where is it? Let's go find it. Yeah. Let's see, this one here. 1 kilogram of S is formed. So when t equals to 1, m equals to 1. Okay, cool. Let's go. I'm running out of space though. Guys, let's not fit that. You know what? I can actually fit it if I move this up. Okay, let's do it. Okay, so when t equals 1, m equals to 1. So I'm gonna, before I do that actually, let me just go 4 kt plus ln. I'll just combine this, combine the logs first. 8 minus m, and then times the bottom by 2, so that becomes 8 minus 2m. Yeah, so when I sub this in, I get t equals to 1. I get 4k Actually, I'll divide the 4 over as well. So I get K equals to 1 on 4 ln. Now, when you sub 1 into there, that's 7. When you sub 1 into there, that's what, 6. Have a quick look at what you have to prove. There it is. Perfect. So therefore, right, if I made T the subject, 4 times that, so 4 times that actually disappears. So it's like 1 over ln 7 on 6. Yeah, quick look. Yep. 1 over ln 7 on 6 ln 8 minus m over 8 minus 2m. Yeah. Now, how's that? That's my answer, right? So put a box around that. Now, yeah, m can never be, by the way, m can never be bigger than 4 because the rate will start 4 minus m there. Can't be negative, right? I can't have a negative rate. So maybe I'll be more specific and go and put brackets around here. Because if m can't be bigger than 4, this guy can never be negative, right? And then you go where 0 and the bottom can't be 4, right? So it can't be equal to 4. Perfect. So seriously, m is in nil. Yep. Perfect, guys. How's that? So even if you couldn't do part 1, you can do part 2, right? By using integration. Not the easiest, but there it is. Now, once you do that, I think the question just says, can you please now find the exactness of S formed after 2 minutes? So I'm just going to copy this slide, move it over so I can actually get some space here. Let's delete this color. Right. Okay, I just want the final equation there. Right. So take that. Okay. So for part 3, yeah, they want me to find m when t equals to 2. Now, this is why I'm confused, right? Because normally they make you make m the subject, right? So that you can find m when you sub in time, right? This, I don't know why they made me find time first, but that's fine. So sub 2 into there, and then it's just the algebra for 2 marks, right? To make m the subject, yeah? So let's do that, please. Sub 2 in, that equals to 1 over ln 7 on 6 ln 8 minus m 8 minus 2m. Okay, it's a bit painful. Bit painful. Now, maybe what I'll do, let me see if I should do this. No, I'm just gonna be heroic. Time the 2 up. And so 2 ln 7 on 6 equals to ln 8 minus m over 8 minus 2m. Now, I need to ln both sides, so if you're smart about it, you use your log laws and actually square that, and then get rid of, and then exponential both sides, right? Yeah. So then you get what? 49 on 36 equals to either that's 8 minus m over 8 minus 2m, right? Numbers are absolutely not pretty, but 49 times 8 minus 2m equals to 36, 8 minus m. Rainbow that now. Have a calculator ready for this. So 49 times 8, 392 minus 98 m, so 36 times 8, 288 minus 36m, 98, 6. I got 62m plus 392 minus 288, 104. Guys, mass 104 divided by 62. Now they want exact form, right? So it's like 1 and 21 on 31. Grams? Is it grams? Let me just check that. Or 52 on 31, no, same thing. It is kilograms, okay. kilograms. And that's it, right? It's a little bit like messy at the end, but hopefully not too bad. Guys, I love this question, right? These chemical reactions, I've been waiting for it for a while, right? Hopefully it'll get more popular. But basically, the construct is that you have two substances. They react, and a fraction of each come to create a new substance, in this case, a new solid, right? And the proportion, right? So the rate of change of increase of that substance mass is proportional to the unused part. That's how you do the question, guys. I think it's a nice question. Hopefully you do too, guys. I'll leave it there. If you like the video, subscribe to the channel, like the video, and yeah, tell your friends, please. Thank you.